Hey class, I'm Mr Thornton, and I'm going to help you get that C in your GCSE. This lesson, fossils. This topic was requested by Henry William Smith and AJ Adkins. Thanks guys. If you've got a topic which you'd like me to cover, then just leave a comment below. The first thing to be aware of about fossils is that they are the remains of living organisms from millions of years ago. And that makes them pretty important to scientists because they allow us to start to figure out how different species have changed over the course of time, and how much they've changed over the course of time, and how quickly they've changed, and how they developed into other species. And it also lets us start to understand where life came from in the first place. Most of the time when we think about fossils, we're thinking about one particular type of fossil, and that's the type of fossil which is formed from the hard parts of an organism's body. So things like shells, bones and wood. This is an important type of fossil, but it's not the only type. The reason that it's a very common type though is because these hard parts are so much more resistant to wear and tear. They're the parts which tend to be preserved for longer. They tend to stick around much longer, and so it's possible for them to be fossilized simply because they last through the process. Softer body parts like skin and muscle tissue, or organisms which have softer bodies, so for example jellyfish, or thinking on a smaller scale things like bacteria, it's much more difficult for these to be preserved. That is because decay will start to break down their bodies long before fossilization can start to take place. Fossilization is a fairly slow process and decay is a lot faster. Occasionally we get lucky. Sometimes the conditions necessary for decay aren't present. Typically we're talking about something which has been trapped between layers of sediment, and it's not possible for the bacteria and the microorganisms which would normally decay that species to actually do their work. So sometimes we're fortunate, but normally these soft-bodied organisms don't get preserved and their remains are disturbed by geological activity, or they're decayed long before they ever get fossilized. There is one more type of fossil which is equally important to the others when it comes to figuring out how life behaved in the past, but it's kind of easily forgotten. This type of fossil is the fossil of traces that an organism was present. That may seem a little bit abstract, but we're talking about things like the footprints of organisms, or the burrows of worms through the soil, or the traces that rootlets of plants have left as they burrowed through the soil. These all leave possibilities for fossilization to take place. The impressions which they form, the holes which they form, these can be turned into fossils as well. So it's important to remember that those traces that an organism was there, they are still something which can be fossilized. Some fossils are interesting because they show us things like how big a Tyrannosaurus Rex was, for example. Some fossils are interesting because they show us that creatures like the Nautilus, this species here, has barely changed over millions and millions and millions of years. It was well adapted to its environment at the time, and it remains well adapted to its environment. Most interestingly of all, recently we've started discovering fossils with finer and finer details as our ability to extract them from the ground has improved. This is why increasingly now scientists are starting to think that many dinosaurs actually had feathers rather than scales. We've started discovering fossils like this one which show that actually there were dinosaurs with feathers. Finally, it's worth considering how fossils relate to other sections of the GCSE Science course. Fossil fuels, for example, are the remains of organisms which photosynthesized and stored the sun's energy and were then fossilized. Coal is the remains of large plants, whereas oil and gas are produced from microorganisms which lived in the oceans. Fossils are also an important piece of evidence for plate tectonics. Prior to a certain date in the fossil record, the fossil record actually matches up across the Atlantic between South America and Africa, for example. This is because prior to that date, South America was connected to Africa, and so these species could walk from one place to the next. They could walk between these two continents. After that date, all of a sudden the fossil records don't match. The two continents became separated by a sea, which then became an ocean, as steadily the two continents moved apart. and so we can pinpoint when it was that the continents started to move apart. It's most obvious if we're looking at Africa and South America because we can see such a good join, and so that's usually the example which you'll look at, but it's true for the entire history of how the continents have moved around and changed. The fossil record is a crucial piece of evidence for that. I hope that video really helps you. If you want to check how well you understood, then try the snap quiz. The link is right here, and it'll also be in the description, along with all the other links for this video. If you want to check out my other videos, then click right here. If you want to download the free app I've made to help you with your revision, then you can click right here. If you want to subscribe to my channel, then you can click right here. Don't forget to leave likes, and if you go to the comments, you can give me feedback and let me know which topics you'd like me to cover next. Good luck in your GCSEs everyone, and thanks very much for watching.